Okay, last rational lesson, 5.7, word problems. Number 1. You have a solution of 20-liter antifreeze. And water. So the combination of the antifreeze and water solution is 40%, which is 40% strong. You want to increase this to 60% strength. How much antifreeze should you add? Okay, so let's start. If I have 20-liter solution and it's 40% strong, that means that 8 liters is antifreeze as we speak. So here's my jug. Right now it is up to here, 20 liters, okay? And I'm gonna go like this to represent 8 liters of that being antifreeze. That's what we start with. Now you want to increase it to 60%. So you're not going to pour water in, you're just going to pour antifreeze in to make it stronger. Okay? So I'm going to pour liquid in there. And when I do, I'm going to color more dark. But what happens to the overall fluid? It also would go up. Okay? And the increment that I add of this is also going to be the amount that this goes up in total. Okay, so here's what we're going to write. The chemical divided by the total fluid is going to be the percent of strength. Okay, so what kind of chemical do we have in here? All together, can you see that I have 8 plus an X amount of chemical? And how much total fluid? How much did I get to at the top of my bucket? I had 20 and then I added an X amount. And that I want to equal 60 over 100. Okay? Oh look, the strategy I'm going to use is 1 fraction equal to 1 fraction, so I can cross multiply. Okay, so that looks like this. 800 plus 100x equals 1200 plus 60x. Okay, move your 60x over there. So that becomes 40x. Move your 800 over there. So that becomes 400. And now we divide by 40. So x is 10, which means I'm going to add 10 liters of antifreeze in there. Okay, example 2. It takes Jeremy 20 minutes to complete a task. If Carl helps, then they can do it in 12 minutes. So if Carl worked by himself, how long would he take? Okay, so here's what we're going to talk about. You have 2 pieces of information we have to deal with. time and rate. Okay? And here we have a Jeremy and a Carl. So I'm going to sort out my information. So it takes Jeremy 20 minutes to complete a task. So that is his rate, 20 minutes per task. If Carl helps, then it takes them 12 minutes. So that would be the time that they work for. So they both work for 12 minutes. So if Carl was alone, how long would he take? So I want to know Carl's rate. Okay, so here's what we're going to do. We're going to say that the amount of job that Jeremy did, and then we add Carl's job done, is going to be the whole job done. So the piece that Jeremy did plus the piece Carl does is going to be the whole job. Okay, so does this make sense? If Jeremy does the whole thing in 20 minutes and he works for 12, he completed 12/20ths of the job. Does that make sense to you? So Jeremy does 12/20ths of the job. Carl does 12/8ths of the job, because we don't know. Together they do the whole job. Okay? So now, looking at this, I can't cross multiply because I don't have one fraction. So I'm going to use common denominator strategy. So I'm going to put everything over 20k. So if I make this 20k, I need to multiply by k. If I make this a 20k, I need to multiply by 20. If I put this over 20k, I need to multiply by 20k. So in order for the equation to be equal, denominators are already equal, the numerators have to be equal. Okay, now algebraically I need to get the k over there. So this becomes 8k on that side, and then divide by 8. So 30 minutes is Carl's rate. And that makes sense to me because if Jeremy does 12/20ths of the job, he is doing over half of the job. So if he's doing more than half, he's faster. So Carl is slower. Okay, next one. Example 3. You have 3 hoses filling up a pool. The first hose, if you just use the first hose, it would take 12 hours to do it. If you use just the second hose, it would take 12 hours. And if you use just the third, it would take 18 hours to fill up your pool. So if they were all going together, how long would it take? Okay, so now we have the same thing as last time. I'm going to sort my information. Okay, so 10 hours alone would be the first one's rate, 12 hours alone would be the second one's rate, and 18 would be the third one's rate. What I don't know is how long they're going to go for. Okay, but that's going to be the same variable because they're all going to end up being the same time, right, together? So remember, we do time over rates. Rate is the job completed. So hose number 1 will do T12ths of the job, or T10ths. Hose 2 does T12ths, and hose 3 does T18ths of the job, and together they would do one job. Okay? Strategy, common denominator. What's common between 10, 12, and 18? The lowest one I can get is 180. So 180 over 180 on that side. Okay, 10, I would have to multiply by 18. So 18t. 12, I would have to multiply by 15. So 15t. 18 to 180, I'd have to multiply by 10. Common denominator is the same, so conclusion, the numerators have to be the same. So altogether, I have 43t, and on this side, 180. So if I divide by 43, the time altogether would take 4.2 hours to fill up the pool. Okay, one last example. A boat travels 9 miles upstream in the same time going 11 miles downstream. The river current is 3 miles per hour. Find the speed of the boat in still water. Okay. So we know, I'm going to give you this formula. Time is equal to the distance divided by speed, right? Because you probably know that speed is equal to distance divided by time. So if you just maneuver that formula, you get time is distance divided by speed. Okay, so I'm going to use this, and I'm going to say the time you go up is equal to the time you do your travels down. Okay, so going up, your distance is 9 miles. Going down, your distance is 11. Okay, when you go upstream, the speed of your boat is going to be your boat speed, but when you're going upstream, you're against the current. So your velocity, your speed of your boat is going to be down by 3. And when you go downstream, you're going faster, so it's going to be your boat speed plus the current. Okay, now once I have it set up, I pick my strategy. One fraction on each side, cross multiply. So we have 9b plus 27 equals 11b minus 33. Move your 9b over there. Move your 33, negative 33 over there. So that becomes 60. And if we divide by 2, the boat speed is 30 miles per hour. Okay, that's the word problems.